All right, so what is the solution? What is the solution to this system? Nobody knows now? I saw it on your whiteboard. What's the solution?
1, -1.
Yes, 1, -1. Did you check your work? Did you check your work? Okay, let me ask this again. Did you check your work? No? You didn't? Okay. How do we check? How do we check to see if we have the right solution?
You input what you got into the equation.
You substitute the value, right? So the solution, the value that you get for x and the value that you get for y, you substitute it into both equations. Now, you gotta make sure that you substitute it into both, not just one, both equations. Because sometimes when you substitute the value into one, it does work, it makes the statement true, but when you substitute it into the second one, it doesn't. Ladies, what's going on? Oh, is that really important right now? Okay, can you put aside your dry erase markers? And I'm going to be doing the lesson on substitution, okay? So we've been learning about linear systems, and substitution seems to be a problem. So that's what we're going to cover today. Take out your notes, notebooks. Okay, so today's topic is solving systems by substitution. And I'm going to write something here, AKA. Do you know what AKA stands for?
Also known as.
Also known as, I'm going to explain what this is, the blob. The blob method. Okay? The blob method. So get that down. Get that down and do we need highlighters, guys? Do we need highlighters? Get those highlighters out. Oh, you know what? I can pass them out. Do you need the highlighters? Yes. A bit of everything. A little bit of everything. Mix with everything. Okay, so, all right, everybody has their items, their materials ready? Okay, I'm ready to get started. Thank you. All right, so our first example here, we're going to start off with 2x plus y equals 5. 2x plus y equals 5. Y equals x minus 4. Okay, first of all, this is the system. We've been working with these for a while. And we're going to use the substitution method to solve the system. And what the substitution method is about is, it means that we are going to use one of the equations and substitute it into the other equation. So the very first thing that you need to do is you need to find an equation that looks like, that has already the variable isolated. So for example, if you see this one right here, it says y equals x minus 4. Y is already isolated. So this equation is the one that I'm going to substitute. Also, when you find the one that is isolated, go ahead and circle this. That's your blob. Okay? That's your blob. So now, you are going to use the blob and you are going to substitute it into the other equation. Okay, so I'm going to go ahead and substitute this into the other equation, and I'm going to write that first equation out. 2x plus, instead of writing y, I'm going to write x minus 4, aka the blob, equals 5. So I'm using this equation, substituting it for the variable. Now I can go ahead and solve the first equation. 2x plus x equals what? 3x. 3x negative 4 equals 5. We have a two-step equation here. We're going to add 4 to this side. Whatever I do to one side, thank you, you do to the other. Okay, 3x equals what? 9. The next step? Divide by 3 on both sides. Whatever I do to one side, I do to the other. All right, x equals what? 3. Okay, so now I've only found one solution, right? Or actually I found a coordinate or a point. That's not enough. I need x and y. So I found 3, but I need y. So now I take this solution, x equals 3, and I'm going to substitute it into the first equation or the second one, whichever. You can use either one. So x equals 3. I'm just going to go ahead and place it on the second one. Y equals, instead of writing x, I'm going to write 3. 3 negative 4, or 3 minus 4. Y equals negative 1. Okay. So now I found the y. Now I have my solution. Now this solution is a point on the graph where these two linear equations intersect. Okay? That's why it has to be a point, it has to be a coordinate. So x and y, this is my solution. Now, how can I check this to see if it's correct? How do I check? Throw the numbers in and okay, so we substitute the values in. Yes, we do. We substitute the values into the variables, for the variables. Great. Okay, now, this is good because the substitution method works when the variable is isolated. But what about if it's not isolated? Okay, if it's not isolated for you, for example, we're going to move on to the next example. 4y minus 5x equals 9. X minus 4y equals 11. Okay. If it's not, one of the variables is not isolated, or neither of the equations have a variable that is isolated. So here for this one, we're going to have to isolate one of the variables. Now, I do not want you to solve this by, I don't want you to solve by elimination. We're going to use the substitution method. So, before we begin, we are going to have to write or rewrite one of the equations. Should we rewrite the first one or the second one?
The second one.
Second one, okay. I should probably move this over to the other side, right? And then that would leave x isolated. So I'm going to go ahead and work with the second one, and I'm going to rewrite that. And I'm going to go, if I rewrite it, I'm adding 4y to the other side. So now I am left with 11 plus 4y. Okay, that's what this equation became. Okay, so once you have your variable isolated, this right here becomes my, what do we call that again? The blob. Yeah. Okay, that's the blob. And the blob is what's going to be substituted. Where are we going to use this?
In the other equation.
You're going to substitute it into the other equation. So every time I see the letter x, variable x, I'm going to substitute 11 plus 4y. So the other equation says 4y minus 5x equals 9. There's the x. Instead of writing x, I'm going to go 11 plus 4y. Go ahead and do that. So we go 4y minus 5. And here, now we have to protect this with some parentheses. Write it out. And then you have 9 equals 9. Okay. So now this becomes a multi-step equation. Distributive property, I heard someone say, yes. So I have to distribute negative 5 to the 11 and negative 5 to the 4y. Go ahead and do that. I just want to check to see your notes to see how everyone's doing. Some of you are really quick at writing your notes and finding the solution already. Okay.